Imagine an iceberg so vast, so heavy it challenges the scale of entire cities. This is A23A, the largest iceberg currently drifting in the Southern Ocean, a true titan of ice weighing close to 1 trillion tons. But what makes this icy giant truly fascinating is its story. One of decades spent trapped beneath the frigid Antarctic seas, before finally breaking free to begin an epic and unpredictable journey. A 23A originated in 1986 when it calved from the Ronne ice shelf, a massive floating extension of the Antarctic ice sheet. To visualize its size at birth, picture an area nearly twice that of Greater London, or comparable in size to the entire US state of Rhode Island. Its thickness is equally staggering, no less approximately 400 meters, or around 1,300 feet, taller than many of the world's tallest skyscrapers. This colossal frozen mass was effectively an ice island, grounded firmly on the seabed of the Weddell Sea for more than 3 decades, rendering it nearly motionless in the harsh Antarctic environment. An extraordinary historical tidbit highlights the iceberg's magnitude and significance. In 1987, a Soviet research station named Druzhnaya Thirst was positioned atop this colossal ice mass. The sudden shift of the iceberg triggered a tense rescue operation to relocate personnel and equipment from a drifting research base, a rare moment where human activity directly intersected with the slow-moving forces of Antarctic ice. The station's existence on such a slowly migrating iceberg exemplifies the immensity and inertial power of a 23A during its prolonged grounding phase. This period of immobility came to an end around 2020, when a 23A began to move once more. After more than 30 years locked in place, the iceberg awoke from its frozen slumber and commenced a slow, deliberate voyage northward. Satellite tracking and oceanographic monitoring, since then, have captured its gradual but steady drift into warmer and more dynamic waters. This marks the beginning of a dramatic new chapter for the iceberg and news, one that has fascinated scientists, environmentalists, and maritime observers alike. Understanding the physical forces behind this awakening involves delving into Antarctic oceanography. Changes in sea temperatures, shifts in currents, and melting at the iceberg's base all contributed to reducing the grounding friction that once held A23A firmly to the seabed. The thawing ice beneath effectively loosened its grip, allowing the immense mass to start moving. This process highlights the delicate balance between cold Antarctic waters and the slowly warming climate, influences that affect even the most massive and stable ice formations. Since its release, a 23A's journey has been anything but predictable. While icebergs naturally drift with prevailing currents and winds, the scale of this iceberg means its movement is influenced by complex interactions between ocean currents, underwater topography, and atmospheric conditions. The iceberg's sheer weight and size allow it to act almost like a floating continent, disrupting local water flow and creating unique microenvironments in its wake. Tracking A23A has required international collaboration, utilizing satellite imagery, aerial reconnaissance, and expeditions by research vessels. One notable encounter occurred in early December 2023, when the British polar research ship RS Sir David Attenborough navigated alongside the iceberg, providing scientists a rare opportunity to collect data directly from the surrounding waters. This allowed detailed study of the iceberg's impact on ocean chemistry, temperature gradients, and marine ecosystems. As we begin this exploration of a 23A's story, it is important to appreciate the iceberg not just as a massive block of ice, but as a dynamic natural entity. Its birth, decades of stasis, and sudden awakening are tied to the broader environmental forces shaping Antarctica and the Southern Ocean. This iceberg saga offers a unique window into the shifting balance of Earth's polar regions in a changing climate, a story of frozen power slowly coming to life. After spending over 3 decades grounded on the seabed of the Weddell Sea, the enormous iceberg A23A finally broke free and began its slow northward drift around the year 2020. This moment marked a significant shift in the iceberg story, from a frozen, stationary giant to an active voyager navigating the complex currents of the Southern Ocean. From the moment it started moving, scientists worldwide have been meticulously monitoring A23A's position and condition, using satellite imagery, radar systems, and oceanographic sensors. Its path has been anything but straightforward. Instead of a smooth journey, the iceberg's travel has been marked by stops, slow spins, and long pauses influenced by underwater topography and oceanic currents. By the end of November 2023, a 23A was spotted drifting near the northernmost tip of the Antarctic Peninsula, a critical waypoint before entering the wider Southern Ocean. This location is notable for strong winds and turbulent seas, which make navigation treacherous not only for ships but for icebergs as well. A particularly remarkable event occurred on the 1st of December 2023 when the British polar research vessel, RRS Sir David Attenborough, sailed alongside this gigantic mass of ice. Despite traveling at roughly 10 knots, the ship took several hours to pass the iceberg's towering wall of ice, which rose over 400 meters from the sea surface. Scientists aboard took the opportunity to collect vital water samples and study the effects of such an enormous freshwater source on the surrounding seawater chemistry. Their research focused on how mineral dust embedded within the ice could nourish marine ecosystems once released through melting. Following this encounter, the iceberg's movement entered a fascinating phase during late 2024. It became trapped in a natural oceanic phenomenon known as a Taylor column, created when a strong current flows over an underwater mountain. In this case, the seamount called Pyrie Bank, near the South Orkney Islands, held the iceberg in place, causing it to rotate slowly and spin approximately 15 degrees counterclockwise each day. This spinning motion dramatically slowed a 23A's progress and showcased the incredible power of ocean currents and underwater landscapes on giant ice masses. Finally, in December 2024, the British Antarctic Survey reported that A23A had escaped the Taylor column's grip. Freed once again, it resumed its northward drift, now carried by the Antarctic Circumpolar Current. This massive current, often dubbed Iceberg Alley by oceanographers, acts as a natural conveyor belt, guiding icebergs through the Southern Ocean, but also funneling them toward more temperate waters where melting accelerates. Throughout this journey, researchers and ship crews have remained vigilant, aware that this slow-moving behemoth poses both scientific intrigue and practical challenges. Each twist and turn, every pause and spin adds to the unfolding narrative of a 23A's odyssey, a story of colossal forces at work beneath the surface of the world's southernmost ocean. As A23A progressed northward into the Southern Ocean's busy shipping lanes, concerns mounted among maritime authorities and environmental scientists alike. Unlike typical icebergs, which tend to be smaller and more predictable, this gargantuan iceberg measures roughly 550 meters at its widest point and extends nearly 2 kilometers in length. Its massive size creates a formidable hazard for vessels navigating the treacherous southern seas. Shipping companies operating in the South Atlantic, particularly those on routes between South America and the Antarctic research stations, have been closely tracking the iceberg's position using updated satellite data provided by the International Ice Patrol. This organization, established in the wake of the Titanic disaster, now employs advanced technologies like synthetic aperture radar to detect and monitor even the most remote icebergs. Because of A23A's enormous size, the iceberg cannot be diverted by small-scale currents or winds, making its trajectory challenging to predict. Ocean models forecast that by late 2025, the iceberg could drift into the Scotia Sea region, an area critical for both commercial fishing and scientific expeditions. Ships in this zone must be prepared to alter course significantly to avoid potential collisions. Beyond maritime safety, a 23A poses an ecological challenge. As it melts, the iceberg releases vast quantities of fresh water into the salty ocean, impacting local salinity levels. This sudden influx can disrupt ocean circulation patterns, which in turn affect nutrient cycling. Marine life, from microscopic plankton to larger species such as krill, depends on the delicate balance of these nutrients for survival. Studies conducted near other large Antarctic icebergs reveal that they can create oases of marine productivity by fertilizing waters with iron and other trace elements locked within the ice. However, the meltwater can also lower oxygen levels in surrounding waters, threatening sensitive species like the Patagonian toothfish, a prize catch in the Southern Ocean. In addition to ecological impacts, the iceberg's immense size means it carries enough fresh water to temporarily influence weather patterns. Meteorologists have noted that large icebergs can alter local atmospheric conditions by cooling the air above, sometimes triggering fog or low clouds, which pose additional hazards for aviation and sea navigation. Maritime authorities have increased the issuance of iceberg warnings and implemented more frequent aerial patrols over key regions. The South Atlantic Ocean, especially near the Falkland Islands and South Georgia, remains on high alert as A23A continues its slow approach. International cooperation between research institutes and naval forces is critical to ensuring safe passage for vessels and minimizing environmental damage. In sum, the journey of A23A is not only a natural spectacle, but a serious test of modern navigation, environmental science, and international coordination. The coming months will be decisive as this iceberg moves closer to increasingly busy waters, reminding the world of the enduring power and unpredictability of nature. As giant A23A continues its gradual drift, scientists are closely monitoring its long-term fate and what it reveals about the changing Antarctic environment. Icebergs of this scale are natural phenomena, but their frequency and behavior provide critical clues about climate trends. A 23A originated from the Ronne ice shelf, one of Antarctica's largest ice shelves, which has experienced increased fracturing over the last 2 decades. Since the year 2000, satellite observations indicate that ice shelves in the region have been thinning and retreating due to rising ocean temperatures and changing wind patterns. These changes contribute to more frequent calving events where huge chunks of ice break away, like the one that formed A23A in late 2022. Experts warn that the iceberg's size, while remarkable, is part of a growing pattern of large ice masses breaking free more often. This phenomenon is linked to the broader consequences of global warming, where Antarctic ice sheets are losing mass at an accelerating rate. Research published in recent years estimates that the continent is losing approximately 150 billion metric tons of ice annually, contributing to rising global sea levels. The eventual melting of A23A will add to freshwater input in the Southern Ocean, with unknown long-term effects on ocean circulation and marine ecosystems. While this iceberg's presence may temporarily alter local conditions, the cumulative effect of melting Antarctic ice globally is far more significant. Scientists are particularly concerned about the potential weakening of the Antarctic circumpolar current, which plays a key role in regulating Earth's climate by distributing heat and nutrients. Moreover, large icebergs like A23A can influence research and logistics in Antarctica. They may obstruct supply routes to research stations or alter local ice conditions, requiring adjustments in expedition planning. Authorities are investing in enhanced monitoring technologies to anticipate these impacts better and maintain safety in the region. Looking ahead, the path and longevity of A23A remain uncertain. Some models suggest it could persist for several years, slowly breaking into smaller fragments as it moves northward, while others predict it may melt completely within 1 to 2 years depending on ocean temperatures. Regardless, this iceberg has already captured worldwide attention, symbolizing the dynamic and fragile state of our planet's polar environments. In conclusion, giant A23A is more than just a drifting ice mass. It is a vivid reminder of Earth's evolving climate and the complex interplay between ice, ocean, and atmosphere. Its journey will continue to be closely watched by scientists and policymakers alike as they seek to understand and respond to the challenges posed by a warming world.